In the previous lecture that we watched, we had to find out the force that was applied, or the force that the bracket could take, and the number of bolts were given to us. In this problem, we have to design the connection, which means that we have to find out the number of bolts which are required, and we have to arrange the bolts in accordingly to take the external load of 300 kilonewton. So look at the diagram which is given to you on the left hand side. It is an I section, ISHB 300, and we are asked to use M20 bolts of grade 4.6 and design the connection. The nominal dia is 20 mm, dia of the hole is 22 mm, ultimate strength of the bolt is 400 Newton per mm square. The thickness of the bracket plate is 8 mm, hence the thickness of the thinner member is the connection is 8 mm. In this problem, since we are given ISHB 300, the flange thickness is, please refer the steel tables for this, is 10.6, and the thickness of the bracket is 8 mm. That's why we consider the minimum of the two. For rolled sections, we know that ultimate strength is given by 410 Newton per mm square. The bolts are in single shear, and therefore design strength of a bolt is given by this formula. And VDB is 45272 Newton. Next, we need to find out the strength of bolt in bearing. For which we need to find out KB, and it's the minimum of these four values. Let us adopt two rows of bolting with edge distance of 55 mm. Okay, so this is an assumption that we need to make, and pitch of 50 mm. This is taking into consideration that it is greater than or equal to 2.5 times 22. Substituting all these values, and the minimum works out to be 0.5076, and the design strength of the bolt in bearing is found out using this formula. Again, we find out that due to the shear it was lesser. Now, there is a moment because of this eccentricity, and that is calculated as P into E. So the eccentricity, this value is 350. it's P into E. This is P. P is 300 kilonewton and eccentricity is 350 mm. And I'm now converting it into Newton mm. That's why I multiplied 1000. And if you want to find out the number of bolts, it is given by number of bolts required per row. This is per row is given by N equals to square root of 6m upon 2 into V into P. Substituting all these values, we get 11.79. So we round it to 12 bolts in each row. Okay, so the total number of bolts would be 12 in one row, and we have two rows, so it will be 12 plus 12, 24. Now, the distance of extreme bolt from CG of bolts is to be calculated. So let me draw the center line first. Okay, and we have the section something like this. So this is what the section should be looking like. So 12 in each row, total 24. Now note here, in this case our value of R is going to be different. So this we had taken is 55 and this is 55. So this is 70 each. Also we had taken the pitch as 50 mm. 1, 2, 3, 4, 5, 6. So this is the CG, this point here is the CG of the group of bolt, and we need to find out the value of R here. So R is nothing but from this distance here to the center of the extreme bolt. That is what we need to find out. So it is R equals to under root of 70 square plus this distance here works out to be 275. 275 square, which is 283.77 mm. Now summation of Ri square we need to find out. So it is 4 times I going from 1 to 6. Okay, since there is 1, 2, 3 and 4, that is why multiplied by 4, this 4 is this, and 6 because there are 6 in each group if we divide it like this. So these are 6 in each group. Okay, so summation xi square plus yi square so we have 6 into 70 square plus 25 square plus 75 square plus 125 square plus 225 square plus 275 square. This works out to be 832 600 mm square. So this value of 70 is xi, and it is the same for all the bolts in one group. So that is this distance. So that is why I have directly multiplied 6. 25 square, 75 square, this keeps on increasing for each of the bolt. That is why so this is 25, this is 75, this is 125, and so on. Okay, so the next we need to find out the force in extreme bolt this is the force F2, and it is equal to Newton. Now tan of theta for the extreme bolt is 275 upon 70. Therefore theta is 75.719, and cos of theta will be 0.24668. The resultant force on the extreme bolt is given by under root of F1 square plus F2 square plus 2F1 F2 cos theta. Substituting all the values we've got, we get 40714 Newton, and this is less than what each bolt can take. So therefore the design is safe. Hence, provide 24 M20 bolts as shown in the diagram. Okay, so in the end you'll need to show this diagram with all the details like the pitch, the edge distance, etc. Thank you.